Hey everyone, this is part 3 of practicing synthesis problems in organic chemistry 2. This is the first question. Try to pause the video and do it on your own, and then we can try to solve it together. Okay, there are multiple ways of doing it, as I always say, but so if you don't get the same solution as me, you might be as well right. So it doesn't have to be like me, but just make sure that all of the reactions that you used, if it's different than the ones that I used, that they're actually true. Okay, so the first thing that we need to do is that we need to remove this carbonyl group. And there are actually multiple ways to do that, 3 ways to do that. Either we can use the Clemmensen reduction, which involves an acidic environment, or we can use the Wolff-Kishner reaction, or we can use a simple hydrogenation, which is neutral. So I'm going to use the Wolff-Kishner reaction, which involves NH2, base, and heat. And what it does, it just remove this, so we get propyl benzene. 1, 2, 3. The next step would be oxidizing a benzylic hydrogen. So remember, if you have a benzylic hydrogen, like this is a benzylic carbon here, and it has two hydrogens. So if you do an oxidation reaction, you just remove everything else and convert this carbon into COOH. So you get a benzoic acid. You oxidize this. So you get this. What you can use to oxidize, like your oxidizing reagent could be KMnO4 or H2CrO4, of course with heat, and you get this. Now there are 2 ways. There is a short way and there is a long way. The short way would be a simple decarboxylation reaction, but I'm gonna do the long way so we can learn more reactions to do that. So what you could do is convert this carboxylic acid into an amide. And the way to do that would be reacting it with ammonia. Remember, amines can replace the hydroxide group because it's a stronger base. And then this is like step 1. So you get here, instead of the OH, you get NH3 plus because it has 4 bonds. And then in step 2, you heat it up to get rid of the excess hydrogen. So you get amide. And as we said in part 1, to remove the carbonyl group of an amide, we can use the Hofmann rearrangement reaction, which involves Br2 or Cl2, strong base, and heat. So you just remove this, so you get amines from amides. So here you have NH2. So we want this amide to leave. So we have to convert it to a good leaving group. So it's best if we convert it to diazonium ion by reacting it with NaO2 with HCl, and you get the diazonium ion. And to convert diazonium ion into benzene, you react it with H3PO2. This reaction releases the nitrogen. It releases nitrogen gas. And that's how you get your product. Okay, this is question 2. Pause the video, try to do it, and then we can do it together. Okay, so as you can tell here, we have cyanide group or nitrile group. And to get that, it's a good nucleophile, and it usually replaces the N2, like the diazonium ion. So here, let's just say we need N2. And to get the diazonium ion, as we said in question number 1 in this video, we need amine first. So here we need to have amine. And to get an amine, you need to do the nitration reaction first. So it goes like that. Okay, so let's do it. So first we need a nitration reaction. So we need to react the benzene with HNO3 with H2 SO4, the acid, and we get a nitro group. Like this is here, we are here. And then we do simple hydrogenation reaction with a catalyst, Bd over carbon, and then we get NH2. Now, you really need to remember this. We said it in a previous video as well. This cannot go Friedel-Crafts reaction because the amines react with the catalyst, react with the AlCl3. So you need to put a protecting group over it. To do that, you can add silk chlorides or you can add acetic anhydrides. Let's just add this. And in that way, we can convert the amines into amide. And that way we can protect it from reacting with the catalyst of the Friedel-Crafts reaction. So we get NH. Remember, this is a leaving group here. Like it leaves like this, and this nitrogen attacks this carbon. Okay, now we protected it. We can do the Friedel-Crafts reaction. So we can react this with like our RCl. This is the R that we want to add. You see? CH3, CH3, and here we need to connect it to our aromatic group. So the amides groups are activating, so it could go ortho or para, but the amide group is large, so because of the steric hindrance, it would prefer to go para. I forgot to add the catalyst here. So now we get this. Let's just, because I'm too lazy, this is X for now, the amide. And here we added the R group. And now we need to hydrolyze the amide group back into the amine because it's safe now. We already got our product. So we hydrolyze it. We get amine here. Okay. And now, as we said, we need to convert that into our N2 group. And to do that, we reacted with NaNO2 with HCl in a low temperature. That way we can get our diazonium ion, which can undergo many reactions. It's very useful. We need a CN, so our nucleophile is CuCN. And that way I can get my product. Okay, this is our final problem. Try to pause the video, do it. As usual, we can do it together. Okay, the way to do that would be, obviously we need to add R groups, because as we said, if we have a benzylic hydrogen, we can oxidize it to a carboxylic acid. So we need to have an R group here and an R group here. Obviously we can't add the NO2 first, because if we add it first, it's too strongly deactivating, and strongly deactivating groups can't undergo Friedel-Crafts reaction. So first we need to add, we need to do the Friedel's Craft alkylation by using CH3 Cl with a catalyst, and we need to do it twice. The first one is going to be here, the CH3 is going to be here, and the second one could be ortho or para, but you can discard the ortho product and only keep your para product. So if you do this twice, you will get this CH3 here and a CH3 here. Okay, either you can also add like add ethyl chloride in the first one, like because it's larger, so it will like it will favor the para product because it's larger, so because of steric hindrance. And we don't care if it was CH3 or CH2, CH3 here, because if we do the oxidation, as long as we have hydrogen here on the benzylic position, we can convert it into carboxylic acid. So a better way would be adding ethyl chloride. Okay, and now we can do the nitration. This is weakly activating, so it's orthopara. So it could be here or here. And do we care? No, because it's symmetric. Now we can oxidize like we did before. H2CrO4 with heat, and we get our product. Okay, thanks for watching, guys. As always, if you need any help, add me on Skype. I'm a free organic chemistry tutor. You can ask me anything. I would gladly help you for free. Good luck.